Hi everyone, and welcome to a new edition of Talks by Softbinator. It's the edition with the number 162, I think. Sorry for keeping my hands where I shouldn't. Tonight we have two very nice presentations. The first one is about the future of developing using remote environments as a service. And the first speaker is Roxana Ciobanu, the CTO of Bunnyshell, which is an amazing startup that's revolutionizing this way of how we develop, and they're providing this environment as a service way of doing. And since since the last time when I found what they were doing, I actually stumbled upon a lot of remote development things being done by other companies like IntelliGPD. They're doing something similar, and all the cloud providers are probably doing a few of them as well. And the second speaker is Mihai Sturza. It will be on AI. We're talking about natural language processing tonight, about word embeddings. But until then, let's get started with development using environments as a service. Roxana, you have the honors. A round of applause.
Hello, thank you very much for participating, for taking the time to be here, and for having me. I'm very excited to be talking to you about environment as a service, which is the future of development. I'll get started by saying a few words about me. This is my name, and I've left a LinkedIn URL there in case you want to say hello, which you are always welcome. I'm the CTO and founder at Bunnyshell. I've started my career as a software engineer. There's a story behind how I transitioned to being a sysadmin, and Softbinator is part of that story, because when I was younger, and I think my second year college, I participated in a talk, and they were talking about the difference between how a developer and how a sysadmin thinks and how they solve problems. And I was very mesmerized by how many problems need to be solved that are not really that, and developers don't know about them. So I decided to transition to that area. And then to the DevOps area, I started working with lots of tools, with provisioning, with infrastructure as code, and monitoring tools, and alerting, and everything. DevOps means everything. And then I transitioned to a cloud architect, started working with cloud providers, doing migration between clouds. And now I'm a CTO, and I find myself working with the same things, with the same people, and it's kind of a complete journey, how I like to put it. Another thing about me, before starting, wait for it. Well, I guess I'm missing the other slide. It doesn't want to show up. But the important thing is that I am an animal hoarder. I am a pet hoarder, and I've had rabbits and bunnies and guinea pigs for some years now, and my husband says that we cannot afford for me to have another hobby than raising bunnies. And that's enough about me. Perfect. So these are photos with my pets. Okay. Perfect. So let's get started now. What does environment as a service mean? Well, basically, it means that your application and your environment are kept together, are packaged, and undergo version control, which means the applications, the infrastructure, all the dependencies, all the links between them, where are they deployed, what technology you are using for deploying, you're using Kubernetes, you're using functions, everything is kept under version control. And what does this give us? Well, the main benefits of environment as a service are release frequency improvement, increases in developer productivity, and also reduces costs for development resources, as I'll show you in the next slide. So how does it improve? In order to improve the release frequency and improve the development life cycle, you have to improve how other departments that work with developers which means the QA department, the automation test department, DevOps, product, and also the sales. The sales is a bonus here. They don't interact that much with developers. They don't speak the same language. I'll start, and my presentation, what I propose here is I'll give you a roadmap of all departments and how the environment as a service concept helps every department, which leads us to our main benefits. I'll start with the DevOps team. The pain points of the DevOps team first is the joys of managing non-production infrastructure. Have you heard of that pain point, of that joy? No, you haven't, because DevOps, and I've been working as a DevOps for a few years, they're not really concerned about production environment. It's not non-production environment. It's not their second concern. It's kind of their 10th concern. They usually work in creating zero downtime deployments for production, for ensuring that the production is fast and the deployments are good and there is no downtime and it's monitored and it's alerted. But for developer infrastructure and staging infrastructure, it's not their concern. So somebody needs to do that, and somehow the DevOps team starts being a bottleneck for developers. Also, the DevOps team is concerned with cost optimization. And here, they sometimes have too little control or too much control. What too little control means is giving all control to developers. And developers are resource hoarders. They like to start lots of instances with a lot of resources, and they kind of form an emotional attachment to their staging environment, even though they don't need it. They leave it there for months, and it's somebody else's job to go and delete those resources. Well, too much control, on the other hand, means that every time a developer needs a resource, they have to talk with the DevOps team. And because it's their 10th priority, it shows a little gap, like a month, or sometimes, hopefully, weeks between when the ticket was created and when it was resolved. And how does environment as a service solve this? Well, it removes the bottleneck for the DevOps team in the development department, and it also does cost optimization. And the way it does that is it gives a way for developers, when they start working on a new feature, on a new bug, to create their own environment that is production-like, that has all the dependencies and all the resources. They can start developing using that specific environment with local or remote developing, as I'll show you later on. They develop and they get feedback very quick from the other teams they work, and then the environment is destroyed when the work is finished. So there is no hanging resources in the cloud. So this was the DevOps team. Now going further to the QA team. The major pain point is that they need dedicated environments to do proper testing. If they test in parallel, they need environments with different application versions. And if they create multiple environments, they always find inconsistencies between them related to data, related to versions, and inconsistent environments is a problem that developers have. The QA team, which is less technical or don't handle inconsistencies that well, they have a huge pain in this. And the way that environment as a service solve this issue is that when a developer finishes working, he creates a pull request. Now the pull request, using the environment as a service product, creates environments production-like, and they have a complete environment in which they can run the tests. Also, a thing to notice here is that when the developer reaches an 80% part of the feature or bug, they can go to the QA and they can test it prior to finishing it, and this way they can get early feedback, which does count when you want to increase the release frequency. The QA says and gives the feedback to the developers, and then developers update that environment, which we call ephemeral or preview environment, and after everything is fixed, the environment is automatically destroyed when the pull request is closed. Going further to the automation team, they are concerned most with regression testing and end-to-end testing. How do you do to test everything that means to be merged into the production branch? Well, every time you create a pull request, environments should respond, and the automatic pipeline for testing should run on those environments. Also, if the tests you test everything like end-to-end testing, you need to run that in parallel, which means you can create multiple environments and run multiple tests in the same time, and that's parallel testing. Again, how does environment as a service solve this? When you do a pull request, when the developer finishes the code and does a pull request, even before the QA manual test, if the company has such a department, the CI/CD can create new environments or integrate with platforms that create new environments and run the automatic tests. The results that are from those tests are communicated to the developer through the Slack channel, through comments on the ticket, through comments in Git, and then the developer updates those environments, updates its developer environment, creates the pull request again, or updates the pull request, and again, they are destroyed. So nothing is left hanging there. The next department is the product department. So the issue here is that the product team is not technical mostly at all. So what is needed here is to provide them with environments so they can give early feedback to both developers and designers. And they really rely on screen shares and review meetings, and everybody likes meetings. Also, not everybody likes meetings. Also, when you provide early feedback, this is again a thing that increases your release frequency. How does it work here? Again, when the developer finishes its work, on the pull request that he does, an environment is created dedicated for the production, for the product testing. And the product can do a user acceptance testing. He can give the feedback, give it to the developers, give it to the designer, even before the task is finished or code reviewed in its entirety. So again, the developer receives feedback, it updates, the feedback is very organic, and then when the pull request, when the feature is good and the QA also finishes testing, it is destroyed upon closing the pull request or merging the pull request. The sales team. So the sales team here is a bonus. Of course, environment as a service can be used by the sales team. And why? Because sometimes there are demos that you need to give to your clients that are specific for those clients and need some working before they are done. So in this case, sales team need their own environment, and it needs to be production-like, because if it's not, you will encounter bugs, you will encounter features that don't work, and that's pretty embarrassing. I've been there. Then it takes too long to set up, because if the DevOps team, again, is the bottleneck here, or in a smaller company, there is a developer that knows a little bit of DevOps, and he does everything, then the sales team will consume the development time on setting up environments. Well, in this case, nice flow would be a salesperson receives a demo request. And you can imagine the possibilities. He receives a demo request which can be a calendar entry. And the calendar can use the API to an environment as a service platform or to the CI/CD and create a new environment, an hour or 2 hours, depending on the prep time, before the call. So there is no DevOps, there is no developer that is even implicated in this flow. After that, after the demo, the environment is destroyed. The salesperson will destroy it if they care about cost optimization. They don't really care about cost optimization, or the environment can have a time to live, which will make it disappear after the demo. Going further, and this is our big chapter, development team. There are a lot of issues, there are a lot of pain points here. So, have you heard, I love managing infrastructure. Oh, I love managing dependencies. No, you haven't, because developers really like to write code. There are some developers that like to do the DevOps, but usually you will have DevOps dedicated teams for that. So they spend a lot of time managing environment, which means managing how they are created, managing the cost optimization, managing dependencies, managing the cloud provider, and so on and so forth. Also, they cannot work locally. Specifically, and not only to that case, we find this case a lot in AI departments, because they cannot run their code locally. They need a remote environment which they can work on, so they don't have their local their laptop explode. Drifting in application versions. What that means is that when you're working in a microservice application that has multiple components, if you have multiple developers working on that, they make changes to a certain application. And then the other developer, if the environment is not updated, then they will run on different version. And that's called drifting, behind the main version. Then there's the security blockers. Well, this is about the bottleneck with the DevOps team or security team. Sometimes developer needs certain resources to the cloud, and if they have their access restricted, which they always do or should have, then they have a bottleneck, and it takes longer to deliver because it takes longer to build environments, so it takes longer for everything. Then the onboarding. Well, onboarding means that you have a new colleague and he has to set up the application, and it's a joy when nothing is working because everyone has scraps of everything, and he's receiving multiple instructions from different teams. So wouldn't it be nice if everything was remotely and he can start working with just a click without needing to have access to everything and then compile it and run it and install thousands of dependencies? Then developers, and I think this, from my knowledge, they hate the most. Forced to work in a non-developer way. Developers have their tools that they love to use. Usually they stay in their command line or they stay in their IDE, and that if you bring something in their flow, it's destructive for them because they have to learn how to use it. It's not something that's familiar to them. So as much as you can keep developers with the product and the tools that they love, you will get better code and you will get more productivity. And lastly, but not the least, non-production-like environments creates bugs. So the saying, it works on my computer, I blame that one. So every time a developer says that it works on their computer, it's because they've been developing on something that is different between his environment and other environments. So in order to do that, each developer has to request, and it needs to be very rapid, an environment that is production-like. So in this case, how would the flow work with environments as a service? A new feature or bug needs to be developed. A bug doesn't need to be developed. You need to develop on a bug. So in that case, the flow is that developer creates a branch and needs to start working. At this step, he will request a new environment. It should be very easy for him. And if you want to keep the developer with his tools, you would need GitOps for that. He needs to put a commit message saying, create an environment for me, to push it, and then in Slack or in his chat app, just to receive the URL, here you are, sir. Start working on that. So this is something that developers would really like. And then start developing. And there is local development and remote development. In local development, and think of an application that is microservice and has 100 components. They don't develop all the components in the same time. They choose 1, 2, or 3, but mostly it's just one they develop. Wouldn't it be nice if they can develop only on that specific service, and when he develops, all the other components are running remotely, he has access to them as if they were local, and those components as well have access to his local development. That way, we don't need all the resources locally, and the developer can start working right away. Also, there is the remote development method. In this one, he goes into his IDE, so it's that kind of a developer that doesn't like even the command line. He starts working in his IDE. His IDE is connected to the remote environment. He starts writing code. The code is synchronized to the remote environment, and everything he writes is instantly showing in the remote URL. So this is kind of heaven for developers. When they've done developing, they create a pull request. At this stage, they need to do code review. They need to ask feedback from the other teams. The pull request creates ephemeral environments or preview environments for the other teams. For example, the first thing that should run is automatic tests. You should run unit tests, integration tests, regression tests, and end-to-end testing even before the QA will look manually in the new feature or bug fix. Then, if that is okay and there is no feedback to be given to the developer, starts the QA with the manual test. Okay? After that, he gives feedback to the developer, and the developer updates the code, and then the product user acceptance testing, which involves the developer and the designer. After everything is done and early feedback is received, then the pull request is closed. At this point, everything is shut down, because at this point you don't need any more environments. Everything that was used by the QA, even the developer, even the product, is closed, and no worries for that, because after you'll be working on a new feature or bug, you can always and very quickly create new environments. What this flow does is the actual improvement of developer productivity and the release frequency, and also the developer satisfaction, which is the most important of them all. And this presentation wouldn't be complete, of course, if I wouldn't tell you about the best environment as a service solution, which is Bunnyshell, which is coincidentally the platform that I work on. So this is Bunnyshell, and please give it a try and give us feedback, and it would be very much appreciated. Thank you very much, and please, I'll be answering questions now.
First, I have a question.
Please.
So how is it easy to get started? So if I want to spin up an environment, what do people, let's say using Bunnyshell, what do people need to do? Do you have like integrations maybe directly with GitHub, where on the pull request itself, I want to test this, launch my environment so I can test it? How does it work?
So the flow is very easy. The first thing that you need to do is connect your Git provider. Okay, so this is the first prerequisite, and then you have to connect your Kubernetes cluster. After you've done this too, you can spin up an environment by going in three ways, really. You can do it from the UI. You just select new environment. You input the application, and the best part here is that you don't really need to write anything else. Bunnyshell checks the repo and checks what application is written in it, and what structures you are using. Are you using Docker Compose? Are you using Helm, or whatever you are using, and spin up the environment like that. You can add multiple applications. So this is the first way. And usually our demos with the clients take from 5 to 10 minutes. So if we can make a demo showing them that we can create an application and access the application in 10 minutes, that's pretty fast. The second way, because developers won't work with the UI as much, is the GitOps part. When you create your first environment, we will create a YAML file for you that you can put in your Git repository. Everything that changes there will change also in the environment, which means the single thing that the user needs to do is to go in GitHub, GitLab, or the Git provider, create a pull request, and after Bunnyshell creates the environment, a comment will be added to the pull request with the URL. So basically, he really doesn't need to do anything, just the pull request.
I have two more questions.
Please.
One is, do you need a DevOps inside your team to get the initial setup started?
No, you don't need. As long as you can connect your provider, which you can, and you have a dedicated Kubernetes cluster, which usually you have access to, because how could you run your applications if not? The setting an environment is very friendly for developers, and not as much. It is friendly for DevOps, but it's meant for developers to use.
Okay. Are there any other questions? And otherwise, I have one more. One more question. At what stage does this make sense to actually be implemented? Maybe cost-wise, how big does the project need to be so that remote development makes more sense than local? Because I'm thinking simple websites, you can do them locally, and it's sort of more complicated and more costly to work remotely.
Well, in my opinion, and it would have been nice if such a product would have existed when we started working in Bunnyshell. And I would think it is good to have it from day zero, really, because the problems that I spoke about, like environment drifting and application drifting, start from day zero. When you have an MVP, when you get to that step, you already have the problems. And also, if you're a new company and a startup, then release frequency and productivity really should be your main concern. After you grow a little, you have other concerns such as sales. But when you just start, sales is not your concern, but building something is your concern. So I would recommend using the environment as a service really from day zero. And also the onboarding. Onboarding means zero.
Okay, awesome, thank you.
Are there any more questions?
Awesome, if not, I have another.
Okay.
I have another question.
Okay.
How do you interact with, let's say I have an application and I have a lot of cloud-only services, like I also have some serverless things and some APIs and some things like that. How do you manage those?
Perfect. So environment as a service means application with all the dependency. This is why Bunnyshell works also with infrastructure as code solutions. Which means, for example, Terraform, if you're using Terraform and you have defined what are the external requirements of your application, such as databases and functions and everything else, even third parties, an environment does not only mean your application, but it also means everything that is surrounding that application, including cloud components and everything surrounding that.
Okay. And how exactly does that work? Do you use the production, let's say a serverless API?
Okay.
Does the environment create a new one that's like that one, or uses the one that's already deployed in the cloud? Or clones it?
Well, here there is a discussion between shared services, and tell me if I'm answering this question correctly. So there is, not all environments should be perfectly dedicated because it's a cost problem. Yeah. So for example, if you're using an RDS instance, usually for stage environments, you don't want to have an RDS service for each and every one of your environments, but you want a dedicated database inside that service. So in that sense, you can have shared services that are shared between the environments, but also dedicated ones. So depending on your application, if there are such components that don't need to be replicated, you can do that. But usually they're not really anything related to production. So it's something that is mainly for development and staging.
Awesome. Thank you.
Thank you very much.
Thank you very much. Thank you, Roxana. An amazing presentation. I hope it's clearer for everyone. If not, for the people that were on the live, we expect you to join our Talks by Softinator group on Facebook and ask your questions there, and Roxana will be able to answer them for you afterwards. Okay, we're now moving on to our next speaker, which is Mihai Sturza. He's telling us everything about NLP and Word Embeddings tonight, and you have the microphone.
Hello everyone. Thank you for having me. Thank you. I hope everyone is okay. I'm very happy to see so many people, and even if not in a physical format, I hope everyone that's online is safe, is nice. I'm really happy that we start having speeches again, because it's been such a long time with actual speeches. So tonight we're going to talk about semantics and creating, and basically how we can enrich our textual data with meaning. I'm Mihai. Okay. Okay, great. So I'm Mihai. I founded Bucharest School of AI some time ago. It was a AI community that started with pretty much two young guys trying to teach AI for free. And right now I'm starting Nevexo Technologies, which is former federal agency where we did software and we're basically a software agency, software agency, that's it. It's working there, but it's not scrolling in here for some reason.
Technical issues.
Yeah.
As always.
We need some environments ready to use. We need some environments right here. Restarting does the job, I hope. Great. So what exactly are semantics? Basically, semantics are meaning behind text and logical sense behind text. So we communicate in a pretty weird way as humans. The way we communicate depends on a lot of factors like language, accent, the way we were born, our knowledge, our history. There are a lot of major variables that play a role in the way we speak. And that might be a bad thing because not everybody might understand the way I explain, not everybody might understand the way I speak, and not everybody might even understand what I say because my English is probably broken comparing me to some native speakers. Computers are pretty much simpler because they're just ones and zeros. So, and after just ones and zeros, we have full control of their structure and the way we work with those ones and zeros. And that may be a problem too. But what happens if we try to combine the power of computers with the information volume of humans? Now, let's see how this idea started. Basically, in the 1950s basically started when computers appeared. People were trying to do basic input programs. I bet everybody in this room has done so. If you program, I bet one of your first programs was, if my input is hello, I'm going to reply with hello, how are you? So these were the kind of programs that programmers were doing back in the day. Just if-else's and structured conditional logic so we can reply and have a conversation with our user. After that, we start with some basic machine learning, basically just doing heuristics and weak AI models like regression. Now, we're in a stage where deep learning is one of our major things in AI, and in 2010, actually, Google passed their Turing test with their assistant. And right now, we also have GPT-3. It's a state-of-the-art model that can not only generate text, but generate code, generate poetry, generate art, generate about everything that is correlated to semantics, which is pretty nice. So how do we do this? I've talked about the history, I've talked about what is semantics, but how can we actually do this as human beings and not as corporations? If anybody has worked with a neural network before, probably will think that neural networks will be fine, but they won't be fine because they can't remember context. Now let's imagine a neural network trying to propagate a sequence of textual data and try to see how hard it will be for it to learn the actual mappings of the words for it to actually work in a real world problem. For example, the proposition of the sky is blue and grass is green, the sentence, sorry. How is that going to be interpreted? What happens if in the test case, we put grass is green before sky is blue, or we put the sky is grass and green is blue? What will happen to the model? It will probably just explode. It just won't work. So people invented recurrent neural networks. What are recurrent neural networks? They are basically normal cells that can remember information based on time. Right here we have an expanded image of a neural network cell, of a neuron, that basically is shown at time, can I point with this?
Yeah.
Oh, there we go. That shows a cell, a specific neuron, at the time of t. And basically the x is the input and h is a hidden, it's a hidden state. Now, if you're going to expand that, each neuron has a representation for every history of every hidden state behind it and probably after it. So if we're going to go to the t timestamp, we're going to have a t minus 1, t minus 2, t minus 3, and so on. Great. So let's zoom in a bit. What actually happens between those timestamps? Those recurrent neural network layers are interconnected with each other depending on time, as I said. Inside them, it's a pretty easy logic. I mean, the schema is pretty straightforward. A previous hidden state, a previous state, is going to transfer its output to the new input, basically concatenate both the new data and the old output of the neuron, activated with the 10H function. Basically, this function just translates the values between -1 and 1. And then pass it in the next hidden state and in the next time step. Basically, when that neuron is gonna be activated again, we're gonna get these old values, do the same function again, and for every time step, we're gonna do that. But there might be a problem, and that is with backpropagation. As we know, even standard neural network neural models have a problem with the vanishing gradient. When we give them a lot of data and they have a lot of parameters, they're gonna start forgetting things and basically not learning anymore after a certain point. That happens too with recurrent neural networks, because we not only need to backpropagate to the actual normal neural layers, we need to backpropagate through time as well of those layers. And that means way more parameters. Let's take a look at how backpropagation works. Basically, we just map a function of the loss function, basically, and we're trying to minimize the cost of that function. When we do that to a recurrent neural network that has a lot of parameters, we're gonna go to a certain point that those backpropagation values, basically the way we update our network, it's not gonna have any effect anymore, and our network will start to even go to overfitting, and that's bad for real-world usage. Now, this problem has been solved with long short-term memory cells. Now, those kind of cells look pretty daunting, don't they? Well, we're gonna explain each part of it, so don't worry. But they are standard. They're copying recurrent neural networks because they have their hidden states and they have this new line that's added, and that's called the cell state. So basically, the cell state is a state that's kept between all the time frames of a neuron, and with that state is basically like a memory. We can delete it with this multiplication and add to it with addition. Now, each long short-term memory cell has 4 neural layers. The first neural layer is responsible with the deletion of all the information, of all context of the model. Now, let's take a look at what actually happens in here. I hope it's not really visible, but basically the old input of the time frame, the old time, the output of an older variant, it's concatenated with the actual input that is passed to the neuron. It is activated with a sigmoid function that gives us values between 0s and 1s. It's a between value, not just 0s and 1s, because we need to calculate the significance of it. So basically, we're trying to teach our neural network how significant is past data. Right here, that's what we do. We look at how significant is past data. Now, the next 2 layers are actually the values that we calculate with the neuron in that specific timestamp. We do the same concatenation of the old values and the input. We pass it to a sigmoid function and a 10H function, and we will multiply them in the next stage. So what we do is calculate the significance of the 10H function, of the actual value that should be propagated by the network. Right now, we'll do the pointwise operations. So the first operation, the multiplication operator, comes from the first layer that is, again, responsible with the deletion of past context. Now, the deletion of past context is made based on the sigmoid function. Let's think about something, let's think about a practical example. So if our model decides that in this segment function, decides that the value is 0, that means that the past memory of this cell state is going to be deleted entirely, because this is a multiplication, and vectors multiplied by 0 will be 0. Otherwise, if it's between 0 and 1, let's say 0.5, it's going to be, or the values are going to be multiplied by 0.5, basically reducing them in half. Okay, sorry for that. And the last layer, the last neural net layer, it's again a sigmoid activation function. We calculate the significance. We then get the data from our cell state, apply it to time h, -1 and 1, multiply with the significance of the current cell, and pass it in the history of time, basically in the hidden state. So they're a bit more complicated, that's true, but we can do way more with those, because these kind of cells don't have the vanishing gradient problem. That means we can have huge amounts of data, huge amounts of parameters, and there won't be any problems when it comes to learning those things. So what exactly is data semanticization, or the part where we extract the meaning from our data? Let's see how it's structured first. So we can structure our data with characters. Actually, every word has characters, every document has words, every corpus has more documents. This is how we structure them. Like, well, it's not, this won't be, you'll probably argue with me that this is not the document, but that's how it's called in standard literature. Now, what are word vectors? So there are multiple types of word vectors. We're going to talk about word2vec. The first and the most standard word vector is one-hot encoding. Basically, if we have, let's say, 300 words, we're going to make a frequency vector and just put a 1 where that position of the word will be. That's pretty much it. And each word will have this frequency vector. Now, word2vec is a vector in a vector in a vector, and basically creating a multidimensional embedding of those kind of vectors. Now, this we'll talk about a bit later and how it works, but let's see, when should we exactly use word vectors? Right now, problems, not every problem requires word vectors, and we can use word vectors to actually get our meaning and semantic meaning from text that we need to correlate with the output of the model. So if we know that a model needs to, let's say, predict sentiment, or predict the next word, or make a chatbot, make a chat with you, we might need to use those kind of word vectors, because they're easier to use, and they put less strain on your model. And we can actually support our models with trainable vector spaces, because, as I said, when training a recurrent neural network, or LSTM, basically, well, recurrent neural network, we need to take into consideration that we actually need to make those mappings, not ourselves, the network will make it, but those mappings might be pretty biased, because what if we don't have enough data? What if our domain is so specific that our model will not perform well on a general scale? So we need to take those steps into consideration, because word vectors might sort us out, might get us out of this situation. So let's talk about word2vec. What exactly is word2vec? It's the most popular solution basically for creating word vectors. So it works with an autoencoder behind. An autoencoder is a model that automatically extracts features from our data. Basically has a big input layer, and has increasingly smaller and smaller and smaller hidden layers until we get to a bottleneck, a very, very small layer. That small layer is then upscaled until we can have the initial size outputted. So right now we have a simple image. We have I think it's a 1. It's from the numerical data set, the popular numerical data set. And this one is passed through the neural network until this small bottleneck, and then the neural networks needs to learn how to recreate this whole image based on those two small neurons. It's not really two, but for visualization purposes. So we can use Word2Vec in multiple ways. We can use SIBO or skipgrams. Right now, Facebook has developed fast text as well. We can use ngrams, but that's a more advanced thing. So SIBO and skipgrams are the main two architectures we can use Word2Vec with. SIBO is basically getting more data, getting more textual data, putting it into the model, and the model gives us the context. And skipgrams is just giving one word, and the Word2Vec is going to give us back the vicinity of that word, basically, the pairs that are in the vicinity of that word. That means we can also do semantic operations. If we represent written data with numbers, we can also do math with them. So let's just see an example right here. You can see that, let's see the last example because it's nice. Paris minus France plus Romania will be Bucharest. Because Paris is the capital, France is the country. If we extract the country from the capital and add another country, it's going to give us the capital of Romania. The capital of Romania. That's the same thing that happens with, let's say, king minus man plus woman will be queen. Or humans plus unity will be peaceful coexistence. If there was a thing. So, Google, right now we cannot really see in n dimensions because we don't have the possibilities for that. We can only see 3 dimensions. But Google has thought on an ingenious way of mapping those kind of words. You can go to projector.tensorflow.org and see this in action. You can basically load a corpus and just click on words or search for words, and you're going to see, as I did with semantics, you're going to see the closest words that relate to semantics. And what are there? Algebra, input, a lot of things. You can try it yourself. So right now, you can try some sample code. If you go to softbinator.mihaisturza.ro, and you're gonna get a Google Collaboratory that has you can connect to an environment and run the code. Maybe we'll see Bunnyshell implementing those things as well. You can go try it out and play with it. Even maybe give them more data and see what happens. That's about it. Thank you for your attention. If you have any questions,
I guess we need to take some questions. No questions. So I have a question.
please.
So how can I get started? How can I use this amazing Word2Vec or something different to do what exactly with it?
To get started, you just have to go here, and you're gonna have some simple code that's linked to the documentation of the code and more videos. I'm gonna add more videos as well. There's no videos.
A few examples for what this would be useful, like real world project.
Well, this project behind this link is a sentiment analysis classification. We basically give in text and gives you a positive or negative labels, or between 0 and 1s. You can use Word2Vectors in any project that needs to classify or that needs to predict continuous values that are correlated with the textual data that's given it as an input.
Okay.
And word vectors cannot really be used only in AI. You can use them in any kind of project that you'll need 3-dimensional spaces to represent words, like semantic operations.
Awesome. So I can build a chatbot.
Yeah.
Smart.
Yeah. You're gonna be more than word vectors, but
okay. Awesome. I guess that's it. No other questions. So thank you very much again.
Thank you. Thank you for having me.
I'm sure people will actually go here and try it, and they'll find bugs or have questions or have suggestions. So please go there and try it out. Try the Google Colab out. And if you have any feedback or questions for Mihai, put them on our Talks by Softbinator group. And thank you again for your presentation, and thank you again, Roxana, for your presentation as well. This concludes our edition for today, and I guess see you all again in 2 weeks. And until then, see you on our social media channels and on our Talks by Softbinator group. Thank you, and see you soon.